Hi everyone, welcome to our day 2 training session of 30-day learning Oracle Goldengate Challenge. My name is Ashish Agarwal, and I'll be delivering this lecture to you. So before commencing the session, just a quick round of update regarding my YouTube channel, which is youtube.com/Ashish Agarwal _GG. So if you haven't visited the channel, I would request you to do visit the channel and do like, share and subscribe the channel. The channel is dedicated to Goldengate related videos. Thank you. So, in today's session, we are going to discuss day 2 session agenda includes Goldengate Architecture, how data flow happens, Goldengate certification metrics. So, how do we check what all things are supported in Goldengate or what all things Goldengate supports? So, we'll be discussing here. Then we'll be discussing about how to download Goldengate binaries and how to install Oracle Goldengate. We'll be discussing about all that. Okay, so let us start with the architecture. So in the previous session, we discussed there are two types of architecture, classic and microservices. Now, because this training is about classic architecture, so let us see how classic architecture looks like and how it works. So you have a source database and a target database. So in the previous session, one more thing we discussed was different types of extracts and replicates available in Oracle Goldengate environment, right? Now, there are different types of extracts and replicates available. So what are extracts? What are replicates? Those questions will be answered to you now. So you have source database and target database. So Goldengate replicates the data from one database to another database. So source database can be Oracle or any non-Oracle supported database. Similarly, target database can be Oracle or any supported non-Oracle database. Now, what happens is each database has its own transaction logs. So as we discussed in the in Oracle database, those are known as redo logs or backup of redo logs, which are called as archive logs. So whatever changes are made to the database, whether those are DML transactions or DDL transactions, those transactions are written into the transaction logs of the database. Now, once they are returned into the transaction logs. So remember, as I mentioned in the previous session as well, the transaction logs contains committed as well as uncommitted transactions. So whatever transactions are returned into the transaction logs, Goldengate extract, there is a Goldengate extract process which reads the transaction logs in sequential manner and captures the committed transactions. So whatever transaction happens on the database, those transactions are captured by the extract process. Once those transactions are captured, the extract process captures them. Remember, as I mentioned, Goldengate captures only committed transactions. So the transaction logs will contain committed as well as uncommitted transactions. So Goldengate is going to capture only committed transactions. Once the transactions are captured, the extract process is going to write them to the trail file on local machine, which are called as local trail file. So the local trail file resides on your operating system. The format of these trail files is binary format. So these are called as the trail file. Now, because they reside on the source system, because they are local to the source database, hence they are called as local trail file. Hence they are called as local trail file. So extract process, whatever it captures. So capture process is also known as extract process. So going forward, you will see two terms, extract and replicate, right? So capture process is called as extract process. So capture and extract are used interchangeably. They mean same. Same way, replicate and apply are used interchangeably. Okay. So extract process captures the transaction, write them to the trail file on local machine, which are called as local trail. Now these trail files reside on the operating system. Once the data gets returned into these local trail, the data pump process reads the data out of your local trail, sends it over TCP/IP network, and writes it to trail file on target, which are called as remote trail file. Now the remote trail file residing on target database because they are remote to the source database. Hence they are called as remote trail file. Now, once the data becomes available into remote trail file, the delivery or replicate process the delivery or replicate process. Sorry, guys. The delivery or replicate process reads the data out of your remote trail and apply it to target database. So, as I mentioned, again, I repeat, capture is also known as extract, or extract is also known as capture. Same way, delivery is also known as replicate, or replicate is also known as delivery process. So, extract process captures the data, writes to trail file on local machine, which are called as local trail. Once the data becomes available into local trail, data pump process reads the data out of your local trail, sends it over TCP/IP network, and writes it to remote trail file on target system. Once the data becomes available into remote trail, the replicate process reads the data out of your remote trail and apply it to target database. So remember one thing, there are three processes involved in Goldengate replication. First is extract process. Second is First is replicate extract process. Second is data pump process. And third is replicate process. So there are three processes involved in Goldengate replication. Extract process work is to extract whatever changes are getting written into the transaction logs. The purpose of extract process is to capture the committed transaction. The purpose of data pump process is to fetch the changes, whatever are returned to the local trail, and write them to the remote trail. And then the purpose of replicate process is to write the data, whatever data has been returned into remote trail, those transactions will be returned into the target database. Now remember one thing, these processes work real time. So as soon as the transaction gets written into local trail, immediately pump process will read it and write it to remote trail. Same way, as soon as the transaction becomes available into remote trail, the replicate process will read the data from remote trail and write it to target database. So if you notice, there are three processes involved in Goldengate replication: extract, pump, and replicate process, or capture, pump, and delivery process, you can say. So each process here has a source to read from and a target to write to. So the source of the extract process is source database and target is local trail. The source of pump process is local trail. Target is remote trail. The source of replicate process is remote trail and the target is target database. So each process here has a source to read from and a target to write to. Now remember, another thing which people get confused or people thinks upon understanding this architecture is pump process transfer the trail file over TCP/IP. No, that's not correct. Pump process transfers the data written into this local trail file and writes it to remote trail file on the target machine. So pump process doesn't transfer the trail file over the network, but it only transfers the data which is written into local trail to remote trail on the target server. So Goldengate also works in bidirectional mode. So bidirectional means both the sides can be live. So the major advantage is this is unidirectional. Unidirectional means application will be connected to site A, for example, and extract process resides on source side, so it will capture and the replicate process will apply it to target side. Now, when it's bidirectional, the major advantage, so one of the major difference between Goldengate and DataGuard is there was a question which was asked in first session as well. Now, another major difference between Goldengate and DataGuard is Goldengate can work in bidirectional environment. Database cannot work in bidirectional environment. Okay. Now, in bidirectional, what happens is both the sites access source and both the sites access target. So whatever replication processes you created from site A to site B, similarly from site B to site A, you will create the process. Now what happens is when the application is connected to site A, your extract process, pump process, and this replicate will come. Now, when you have site B replication available, when you have application connected to site B, in that case, what is going to happen is whatever transactions happens on site B, it will be returned to the transaction logs of side B database. So you will configure extract process on side B server or database, write it to, once the transactions are captured, it will read the transaction from the transaction logs of side B and writes it to local trail on side B. Once the data becomes available into local trail on side B, the pump process created on side B will write the data over TCP/IP network to remote trail on site A. Once the data becomes available into remote trail on site A, the replicate process configured over there will apply it to site A database. So remember one thing, these processes like extract, pump, and corresponding replicate created from site A to site B are different and does not cause any overlapping with the processes like extract, pump created on site B and data getting replicated to site A. So these set of processes are independent. Same way, the other set of processes are independent of each other. So these processes are completely independent. Okay. So Goldengate, the advantage of Goldengate is it works in bidirectional environment as well. So what happens here is extract process captures the transactions, committed transaction upon reading the transaction logs. Remember, Goldengate captures the transaction in commit sequence number. So the transaction getting committed first will be captured first by the extract process, then the transaction which is getting committed next. So the extract process will capture the transactions, write to local trail. Once the data becomes available into local trail, the data pump process will read the data from local trail, sends it over TCP/IP network and writes it to remote trail. Once the data becomes available into remote trail, the replicate process will apply to target database. And same way, your bidirectional replication will also happen in your environment. Okay. So these are the three processes which are involved in Oracle Goldengate replication. So there is a question. Any threshold when pump will transfer data from local trail to target the file? It is real time. So as soon as data becomes available into local trail, it will write the data to remote trail. Then what is the use of pump in GG replication? The use of pump is to sense that to transfer the data from local trail to remote trail. So basically, it's the data messenger in your environment.
Sorry,
Then
Ashish, sorry to interrupt.
could you give example of use case of bidirectional? So as the session goes on, there will be lot of, when we discuss bidirectional, there will be lot of examples which we'll be discussing. But because if you have asked that question, I'll just answer it now. So one of the scenario was, I was working for one of the leading telecom company of UK. So they had two sites. One was Rochdale, like it's the city name. So one was Rochdale and second one was London. They used to send so what used to happen was customer used to send some file. So it used to either send it on Rochdale database or either on the London. So wherever it comes, the data should be replicated to other side. But there are multiple use cases or the test cases of this bidirectional. Okay. Now there is a question, means we need to use EXPDP and IMPDP utilities. Okay. So guys, there is, okay, that is good point what Deba Pratim has made. So remember one thing. Okay, that is good point. With this question, very good point came in my mind. Okay, so this is not database data pump, guys. Okay, before we proceed, let me tell you one thing. So during this training, there are two terms which you'll see which are common between database and Goldengate. One is data pump and second is checkpoint. Okay, now these two are different. These two are different in Goldengate than what we are using in database. So this data pump process is a this data pump in Goldengate is a Goldengate process. Okay, like your extract pump. Data pump is a secondary extract. Capture is your primary extract. Data pump is your secondary extract, which you'll understand. But data pump is a process here. It's not IMPDP, EXPDP. Don't get confused with that. Okay, same way, during this training, you will understand one more term which is called as checkpoint, which we use in Goldengate for data integrity purpose. So until and unless we mention, it means we are talking about Goldengate data pump and Goldengate checkpoint until and unless we mention. So whenever during the training I'm mentioning the term data pump and or checkpoint, it means that I'm referring to Goldengate checkpoint until and unless I specifically mention that it's a database checkpoint or database data pump I'm talking. Okay, very good point. With that question, that is very good point which came. Okay, so now there is one more question, which is what will be the difference between extract trail and replicate trail? So there is no difference basically. The format of this is same. It's just that data wise, whatever pump process reads the data from local trail, replicate process will receive only that much data. The major difference is the local trail resides on source system, the remote trail resides on target system. That's the only difference. Apart from that, the format is binary format wise they are same. The format of these files is trail files is same as archive log files of the database. The format is same absolutely. You cannot read them directly. There is a separate utility to read these trail files, which we'll be discussing later on, log dump utility. Okay. Now, in the previous session, we discussed one more thing, which is integrated extract. Okay, so this is where this is called as classic extract. So the classic extract, when it directly reads or connects to the database and directly reads the transaction logs of the database, it is called as classic extract, just like it is happening here. So the extract process establishes the connectivity with source database, and then it directly reads the transaction logs of the database. So it is called as classic extract. Now, we discussed about integrated extract. We mentioned in the previous session that Goldengate also now has new feature, which is called as integrated extract, right? So what is integrated extract and how it works? So integrated extract works on the feature of logminer database. So what happens is you have a source database. Whatever changes happens into the database, those changes gets recorded into your transaction redo logs and archive logs. Once the changes happens over there or gets written over there, the copy of those changes gets written into the logminer database. So the same data, whatever is written into these redo logs, the copy of those changes gets written into the logminer database. Now what happens is whatever changes are required by the extract process, the extract process will receive those changes in form of LCR and then will write them to the local trail files. So LCR stands for logical change records. So I again repeat, what happens in classic extract is classic extract directly establishes the connection. It reads the transaction logs of the database and whatever transaction it has to capture, it directly captures it. However, in case of integrated extract, logminer does the task. Logminer database, basically whatever changes happens to the database, those changes gets written into logminer. Then logminer passes on the changes to the extract process in form of LCR. And once the changes are captured by the extract process, it is going to write them to the local trail file. Okay. Now, one thing I want to tell you is the performance of this integrated extract is 5 times faster than the traditional classic extract. But how come is it possible? If we look here, the classic extract here, it is establishing direct connectivity with the database, and there is no mediator between the two. Extract process is directly able to establish the connectivity and fetch the transactions. However, here, if you see, between redo logs and archive logs and Goldengate extract, there is one more utility which is called as logminer. So how come the performance of integrated extract is faster than the classic extract? Anyone would like to answer this? Does it make sense, my question? I again repeat. In case of integrated extract, there is one utility in between which is called as logminer. Logminer passes on the changes to the extract process, whatever changes are needed by the extract in form of LCRs. However, in the classic extract does a task. It establishes connectivity with source database, and then it fetches the changes whatever it needs and then writes it to local drill. So how come and I'm saying second statement I'm making is the performance of integrated extract is almost 5 times better than classic. What could be the reason? So Akeem is saying there is no overhead. Pigai is saying logminer has already done all the tasks. So what do you mean by all the tasks? So you are somewhat close, Pigai, but yeah, that's not the exact answer. Anyone else would like to answer this? So my question is,
Sir, in
logminer,
classic, it will be applied sequentially.
sorry?
In classic architecture, it will be applied sequentially, one by one.
No, that's not the answer. No, have I mentioned anywhere that it is applying one by one or integrated is doing parallelly? No, that's not the correct answer. Okay, Pigai is saying that filtering committed from non-committed transaction. I think Pigai, you know the answer, but you're not able to like phrase it well. But yeah, you know the answer. Okay, I'll answer this for you. Now, what happens is Goldengate is a product which works on the application data. Okay. Like, say, for example, you want to capture the data of HR and Scott schema in the database. So Goldengate is going to capture that database. However, your transaction logs contains the transaction all the from the complete database, like sys transactions are there, system transactions are there, and other databases which you might not be replicating using Goldengate. In Goldengate, you can pick and choose. You will see going forward. You can pick and choose what you want to replicate. Right? Now, what happens here is when Goldengate is able to capture the transaction. So what happens in case of classic? So suppose I'll give you one scenario. Suppose in the transaction logs of the database, you have got, first of all, sys transactions with our 1,000 transactions, 10,000 transactions. Then system transactions are there, which are 100,000. Then there are HR schema two transactions. Then again, there are sys 100,000 transactions, system 10,000 transactions. And then again, after that, Scott schema 2 transactions are there. Right. Now, what happens in classic capture is classic capture reads the transaction logs in sequential manner. Okay. And captures only committed transactions. Okay. So here what will happen in classic capture, what is going to happen is it has to read these transactions sequentially. So it will read sys transaction, system transaction, and then when it finds HR related transactions, it will capture them. Then again, it will take system and sys transactions, and then after that, it will find Scott schema, and then it will read the transaction. Now, remember one thing, Goldengate is a product which is external to the database. So in fact, the extract process which you configure, it is external to the database. Now, because it is external to the database, it will take the performance wise, it will take a hit. But in integrated extract, what happens is the same task is done by the logminer. Logminer is internal to the database. It is the same logminer which is used to read the transaction, which is used to read the archive logs of the database. So suppose if you have to mine the archive logs of the database, so you use logminer utility. So the same thing it is. So this is a logminer which is internal to the database. So here the extract process was doing this task for you, like capturing the transactions, whatever is needed. But now whatever extract process needs, that task will be done by the logminer process for you. So logminer will basically provide the extract with HR transactions and Scott transaction, and performance wise it will be very good. The reason being logminer is internal to the database and it will do that task. So what happens in integrated extract is whatever transaction gets returned into the redo logs, copy of those changes gets returned into the logminer database. Now, once logminer has the data, it passes on the changes to the extract process in form of LCRs. And once the extract process has data, it will write that data to the local trail. So, in case of classic extract, the work was done by the extract process, which is external to the database. Hence, performance was slow, and it was reading the transaction logs sequentially. However, here the same task is done by logminer, and because logminer is internal to database, it is much faster and performance wise it is very good. So the performance of integrated extract is 5 times faster than the classic extract. Okay. Now, internally, there are 4 processes which runs an integrated extract, which does this task for you. What we are discussing here, internally, there are 4 processes of integrated extract, which makes it fast. Reader process reads the data, prepare process prepares the data, builder process builds the data, which is then captured by the extract process and passed on to the extract process. So there are 4 processes internally which runs an integrated extract: reader, preparer, builder, and capture, which then passes on the data to the extract process, which subsequently writes the data to the trail file. Okay. So integrated extract performance is 5 times faster than the contemporary classic extract process. Okay. Now, let us now discuss about. So there is a question from Robin. Do we have to use Armin L0 backup to start with to set up database, and further the extract trail will be created for archive, redo logs, and will sync the target via pump? Robin, so this question I want you to hold for some time. When we discuss initial load, we'll be discussing. But what you are asking, that your understanding is correct. But yeah, we'll be discussing about this. You can either use export, import, or Armin level 0 backup to load the data. Okay, there is another question. Contents of both local trail file and remote trail file will be same. It may be or it may not be, depending on the configuration you choose. So again, that question will be answered for you when we do the setup. Okay, now there is another question from Heman. Why can't we have single source of trail file in shared nest point that might performance? So there are 2 different servers having single trail file is not going to, if your database is, if you're using Goldengate Hub, or if you're using database on same server, then it's possible. Or if you use Goldengate as a hub, you can use single source of trail file. That's possible as well. So Debapratim has a question. Can we use integrated capture architecture? Guys, again, I repeat, there are only two types of architecture in Goldengate. First is classic, second is microservices. There is no integrated architecture at all. Okay. So I won't take that question until the question is put in correctly. Guys, my main motive for you is, when you are out for when you are going out for any interviews or any Goldengate consulting you are providing. Okay. So my motive is to ensure you are using right terminology, you are using right words, and you are providing, you are confident in your words. So I'll be preparing you for that during the training. So now the question, Deba Pratim, I want you to, if you want answer to the question, please type in your question properly. Again, I repeat, there are only two types of architectures. One is classic, second is microservices. There is no integrated architecture in one. Okay. Sean has a question. How about very data? I didn't get your question. What about, we are not discussing about very data. This is about classic architecture. How does logminer read the data from the redo log? The copy of those changes gets written into the logminer database automatically using internal process.
Sorry to interrupt, Ashish.
Can we use microservices architecture while replicating data from on-prem to any cloud? Yes, you can use any type of architecture. Veridata is not an architecture. Veridata is a separate product. There are only two architectures, classic and microservices. Veridata is just a monitoring tool, which is separately licensed. If we use NFS file system, same extract trail can be used for source and target system. Yes, if you use Goldengate Hub, yes, you can. But again, we are not going to discuss about that right now. When we do the setup, we'll be discussing about that. Okay, so now what we are going to discuss about is, in the previous session, there were multiple questions about what Goldengate supports and what type of database it supports. Right? Whether it supports MySQL, whether it supports Postgres. So all those questions will be answered for you in today's session. So what we'll be doing now is, we'll be deciding on how, we will be discussing on how to download Goldengate binaries, what things you need to consider before installing Oracle Goldengate. We'll be discussing all about that. Okay. So installation. So now you are into the environment. You have been hired as a Goldengate consultant. Now they have the requirement to set up Oracle Goldengate in your environment. Okay. Now, because they have the requirement to set up Goldengate in your environment, Goldengate is not set up. You are working as a Goldengate consultant for them. They ask you to set up Goldengate and tell them the requirement what you have, whether the server related requirement, whether the space related requirement, or any other requirement. So you need to, what are the considerations you need to follow for installation? Let us discuss about that. So there are few considerations you need to keep in mind. First and foremost, related to the server is, before proceeding with the installation, you need to define the location where you are going to install Oracle Goldengate. You can either install Goldengate in separate mount point or existing mount. It's up to you, but you need to define that as well, right? So before proceeding, you need to identify what location you will be installing Goldengate on. Either you are going to install Goldengate in separate mount point like /Goldengate, or existing mount point like /data or /u0. It's up to you. Okay. Once you have identified that, then the next question comes, how much space you need for installation? Because how much space you are going to request for installation purpose. For that purpose, you need to understand the requirement. and some research is required. I'll give you basic calculation method what I use for calculating the space for installation. I'll tell you. So now what are the hardware requirements? So now when you are setting up Oracle Goldengate, they also ask you what are the hardware requirements for Oracle Goldengate. So suppose they just have the database, they're not using Goldengate in their environment. So they will ask you, right? What are the hardware requirements in Oracle Goldengate? So, and you are asked to provide. So first and foremost thing is number of CPUs. How many number of CPUs you need? So Goldengate generally works well with 4 or 8 CPUs. So you can request for 4 or 8 core CPU. That would be fine. Second thing comes is space requirement. Whether you want to add new mount point like /Goldengate or use existing mount. So now even if you want to use existing mount point, you need to add space for Oracle Goldengate because Goldengate will consume hard disk space because of those trail files. Those trail files resides in the operating system. So you need to do the space calculation. So space calculation on what basis you can do? I'll tell you, each person has their own way of calculating. How I calculate is, let me tell you. What I do is I gather last 30 to 60 days archive log data generation. Okay. For last 30 to 60 days, I identify how many logs, archive logs have generated each day. So suppose one day it generated 20 GB, second day it generated 1 GB, then one day 100 MB was generated and another day 100 GB was generated. So what I do is I take out average of highest 7 days highest archive log generation. So what I do is basically, so out of, in last 60 days, first of all, I identify highest 7 days when archive log was highest. I identify those days. Then I take the average of those 7 days, and then, so suppose the average of those 7 days comes to 25 GB. It comes to 25 GB. Now you have agreement with the client that you're going to keep 7 days trail file in your environment. So what I do is I multiply 25 into 7, which comes out to be 175, right? And then considering future environment, because in future data growth will happen. So I consider that as well. I'll multiply it by 2 or 3 times and will request for around 500 to 600 GB of space. This will ensure that I have done future analysis. This will ensure that if the growth in future is there, I'm prepared for it. I have already done analysis for it, and I will not require any additional space if data remains consistent or growth in a linear way, right? So I follow this calculation. Now you can request for 500 to 800 GB. When I ask for it, I ask around 5 times of it. You can always justify. You can say that you are doing it considering future in mind because archive log generation will happen and other things. Okay, and then so first thing is how many CPUs you need. Second thing is space requirement. Third thing is you need to identify or you need to decide which OS user you are going to use to install Goldengate. So in some of the environment, you might have seen you install Goldengate using Oracle user. While in some environment, you see you must have seen you install Goldengate using GG admin or GG or any other Goldengate user. So you can choose any of the two. Just ensure that that user should be part of O install. That user should be, if you are using any other user like GG user or GG admin, OS user we are talking about, you have to ensure that it is part of O install database. Okay, so what happens is, if now in many organizations, what happens is DBAs are the one who manages Goldengate as well. If that's the case, you can use Oracle user to install Oracle Goldengate. Now in some of the environment, what happens is Goldengate and DBA responsibilities are segregated. That means Goldengate team is different and DBA team is different. In that case, what happens is they use a separate user apart from Oracle, like GG user or GG admin, and install Goldengate using that. But you have to ensure that GG user or GG admin user should be part of oinstall database group. Okay, so these are the installation considerations you need to keep in mind before you proceed to install Oracle Goldengate, or you need to provide the guideline in your project. Now, suppose you have been asked to provide Goldengate is running, and for the future growth, you need to do analysis. So you can follow the same number of steps in your environment. Okay, now each person has their own way of calculating space criteria. I follow this. It's not like I am correct and they are wrong, or they are correct, I am wrong. No. Each person has its own way to calculate or do this thing. I follow this way. If you have any other way, follow that. That should be fine. Okay. Okay. So these are the installation considerations. Now, let us proceed to download Oracle Goldengate binaries. But before we can proceed to download Oracle Goldengate binaries, remember one thing. Goldengate binaries are specific to each database and each platform. That means that Goldengate binaries for Oracle are different for Goldengate binaries for MySQL. Same way, Goldengate binaries are different for SQL Server. Goldengate binaries are different for Postgres database. So for each database, Goldengate binaries are different. Same way, platform wise, they also differ. So Goldengate binaries for Oracle on Linux is different than Goldengate binaries for Oracle on AIX. So Goldengate binaries are specific to each database and each platform. So before you proceed to download Goldengate binaries, you need to note down few things. What are those? Source database, type, and version. Then source platform, OS platform, type and version is possible. Same way, you need to note down target DB type and version, and target OS platform, type and version. You need to note these things. So in our case, we have got Ggate 1 and Ggate 2. Okay. So on Ggate 1, we have got Oracle database 19C. Same VMs are with you. So once you log into, so the password of Oracle user is Oracle, and the password of root user is root. OS I'm talking about. So once you log in with Oracle, just do lsnrctl. You can start the listener. Okay. So here, if you do SQL plus slash sysdba, so echo dollar oracle underscore. Yeah, it's OGGDB, and then why it says it is connected. Okay, so we can start the database. So what you need to do, you need to log into the database, log into the server. Over here, start the database, startup. Start the listener and start the database. Same way on Ggate 2 as well, these are the virtual boxes which are provided to you. Once you import them, then echo dollar oracle underscore SID here. It's OGGDB2. So SQL plus slash. So first of all, start the listener. Exit and do SQL plus slash as sysdba. startup. So now we have got multi-tenant architecture here. Multi-tenant means container pluggable. So this is the container database which has been started. Now we also have one PDB here, which is PDB1. So you need to do alter pluggable database PDB1, open, read, write. Same way, you can start PDB2 here. So your virtual boxes are ready. Alter pluggable database PDB2, open, read, write. Okay, so your virtual boxes are ready. So basically here we have got, I'm just going to tell you the source database name. So these are the multi-tenant databases. So multi-tenant database are the ones which have container and pluggable. So one container database can have multiple pluggable database. So here we have got on Ggate 1, we have OGG-DB1 container DB name. And inside them we have got PDB1 pluggable database name. Same way on Ggate 2, we have OGG-DB2, which is container DB name, and PDB2, which is pluggable PDB name. Pluggable database name, I should say. Pluggable database name. Okay. So now the database version which we are using here is 19C. The database version which we are using here is 19C. So we have to go ahead and download the binaries, right? So before we go ahead and download the binaries, we need to know what is source database type and version. So the source database type is Oracle and version is 19C. What is the source OS platform? So the OS platform is uname-a. So the source database platform is, you can find from OS command uname-a. The source platform is Enterprise Linux 7. It is Enterprise Linux 7. It is Enterprise Linux 7. Same way on target side, we are using same source, same type of database and platform on target. So it will be Oracle 19C and the platform, the target version is Enterprise Linux 7. Now it is possible, like in your environment, your source is on different database type and different target is on different database type or version. It is possible. So your download might change accordingly. Okay, now once we have identified our source database and target database types and platform, next thing is we will go ahead and check the certification matrix. So before we go ahead and download the binaries, the next task is to check the certification matrix to ensure that the version which we are going to use supports this database and platform. So how do we check the certification matrix? Let us see. So to find the certification matrix, the location of certification matrix, you can go to Google, and on Google you can type Fusion Middleware certification matrix. Goldengate is a Fusion middleware product. So you can type Fusion middleware certification matrix. Go to the first link. Now here you can find all certification matrix, Fusion middle. Like here you can find Goldengate 21C certification matrix, 19C, 18C certification matrix. If you go below, you can find 12.2 certification matrix, 12.3 certification matrix. In fact, you can find 11G certification matrix here as well. Same way you can find Veridata certification matrix. So all Fusion middleware 11G R2 certification matrix is there. So you can find all Goldengate version. Or I always say one thing, like whether you are working on any technology, if you want to be right first time approach, follow the certification matrix. Any technology in this world, whether you're working on Informatica, whether you're working on ODI or any other technology, you name a technology. In fact, Oracle database, they come with the certification matrix. So do ensure that the platform you are using, the database version you are using, it supports that. See, I have seen people, what happens is they download the binaries, they try to install, but after that it doesn't work. What happens is they waste their time. Second thing is, in front of the client, it doesn't make good impression of you, right? So it's always good if you're right first time. If you follow the correct approach, you will be right first time. So this is what it does. So open the certification matrix for 21C Goldengate. So another question which I'm being asked is, which certification matrix should I be using? Or sorry, which Goldengate version should I be using? So I always say one thing: use the latest supported version. So check 21C certification matrix, download it, and see whether your environment supports it or not. So I'll go to Goldengate. Here, editing. Go to Goldengate. Okay. Now here, so if you see here, this Goldengate 21C, what type of date? Just 1 minute, something else is happening when I am. It's not working well. Just 1 minute, guys. I've already downloaded it. I'll use that one. It's the same thing. It's just that I don't know why in my machine it's not doing well. Okay, so let me do enable editing. Okay. Now, if you see here, it shows you what all databases it supports. So there was a question yesterday whether Goldengate supports this OS. So this 21C supports these OS versions, whatever you see. It's not like if you don't see your version over here, it doesn't mean Goldengate doesn't support that. Check the certification matrix of 19C. If 19C doesn't support, check 18C, check 12C, check 12.2, 12.3, or 11G. If none of them lists your database or none of them lists your platform, that means Goldengate doesn't support it. So I'm checking Goldengate 21C certification matrix. So Goldengate 21C supports these OS in the same way. Which databases it supports? It supports these databases. It supports Amazon Aurora MySQL, Amazon Aurora PostgreSQL. It supports Amazon RDS for Postgres. All these. Azure SQL database, IBM DB2 for IBM DB2 for ZOS, MariaDB, MySQL database, Oracle database, PostgreSQL and derivatives. So Goldengate supports a Postgres databases as well. So check the certification matrix. So if next time you have a question whether Goldengate supports this database or this platform, you should not be asking that question. You should be going to the certification matrix. Check the 21C certification matrix first of all, or the latest available version at that time. If you don't find it, it doesn't mean that if your database is not listed here, like Informix or any other database, it doesn't mean it doesn't support. No, that's not the case. It's just that 21C binaries are not yet out for that, may not be out for that particular database or platform. So what you can do is you can search for the prior versions certification matrix, and then there you can find. If none of them list that, that means yes, it's not supported by Google. Okay. So now in our case, the platform which we are using is, the database which we are using is Oracle. So I'll filter this out based on database. So I'll select Oracle database. So when I search it, when I select Oracle database, so you see Goldengate 21.3.0.0.1, Linux x86 64, RHEL 7 or 8 is supported by 21C. So we have got the database, Oracle database, and Enterprise RHEL 7 we have. So 21C should support. But now we need to check what database version 21C Goldengate supports. So Goldengate 21C supports Oracle database version 11.204, 12.1, 19C, and 21C. So we are good with it. So our database version is 19C. That means we can use 21C in our environment without any issues. So in our case, we can go ahead and download the Oracle Goldengate binaries for source as well as target. Now, it is possible in your environment that your source is on different database type and platform, and target is on different. Then you need to check certification metrics for the other databases. Okay. So now what we are going to do is we are going to go ahead and download the binaries. How do we download the binaries? Let us see. So to download the binaries, I'll type download Goldengate 21C. So there are two ways to download Goldengate binaries. First is you can download from OTN, Oracle Technology Network. Or second option is you can go through your edelivery.oracle.com. So if you don't find your version over here, you can find it from edelivery.oracle.com. Okay, so this is Oracle OTN from where we'll be downloading. So now 21.3.3.0.0. Now here you will see that there are two types of binaries. First is Oracle Goldengate 21.3.0.0.0 for Oracle on Linux. Then second is Oracle Goldengate 21.3.0.0.0 microservices. So the one which says microservices, it means those are microservices binaries, Goldengate microservices binaries. And the one which says nothing like it, which only lists out the version, that means those are the classic binaries. So because this training we are doing on classic architecture, so we'll select first one. So you see here, Goldengate binaries are different for different databases and platforms. Like this is a binary for Oracle on Linux. This is the binary for Oracle on Windows. Then this is microservices binary. Then this is the binary for DB2 for on Linux. Same way, if you go below, you can find this. These are the Postgres binaries. These are SQL Server on Linux binaries. These are SQL Server on Windows, Teradata on Linux. So different binaries. So each platform, each database has its own binary. So we are going to go ahead and download this binary because we are going to use classic architecture. So we can use this binary. Okay. Once you are done, select it and then download the binary. Binary will be downloaded. It will ask you for your username and password, Oracle. Once you are good with that, it will allow. So Goldengate binaries are around 700 to 800 MB. They are not that big. Okay, so there is a question from Pratap. In classic architecture, can I use remote machine for extract process group? Does it work in latest GG version? Yes, it is. It is called as Goldengate Hub, which we'll be discussing in our subsequent training session. Is there any specific parameter to set CPU count for GG or it's DB CPU count? It's the normal CPU cores. You cannot define anything particularly for Goldengate. So we are talking about CPU, number of CPU cores at the server level. How about we have two different databases? What software we use? So each database you will have to use separate software. So if your source is on Oracle, you will have to use the separate software. For target, you will have to use the separate software. Okay, so now once the binaries are installed, you can transfer them on the server. Okay, now in our case, the virtual boxes which are shared with you, these are your Ggate 1 and Ggate 2. So guys, on your these virtual boxes, if you see this clock and you are not able to click anywhere, just press any key on keyboard and it will prompt you to provide the password. So password of Oracle is Oracle and root is root. Okay, now here on these virtual boxes, the binaries are already present. So the location of binary is data /home/Oracle, softwares. So here you can find the binaries. So the location, so in these virtual boxes, I've already provided you the softwares. So the software location is /home/Oracle/software. So you can find binaries for classic 19C, classic 21C, then MSA 21C binaries are there. Then Goldengate Veridata 12.2.1.4 is there. Then Goldengate Veridata 12.1.2.0 is there. So on these virtual boxes, you can find your Goldengate binaries present. So what we are going to do is, in the next session, we'll be discussing about how you install Oracle Goldengate. So binaries are downloaded. In the next session, we'll be discussing about how can you install Oracle Goldengate. So the multi-tenant, with this training, we'll be using multi-tenant databases. So multi-tenant means one container can have, multi-tenant means CDB and PDB. So one container can have multiple pluggable. The whole purpose of using multi-tenant database is sharing the resources among multiple databases. So if you say, for example, if you create three standalone database in one server, and if they're not sharing resources, the resource waste will happen. You may define the extra SGA, and that SGA is not used by one particular database. But the purpose of multi-tenant database is to share the resources. So say, for example, 4 GB of SGA is defined for one container database. So that SGA will be shared among one or two or three pluggable databases. So we'll be discussing about that as the session goes. Okay, so in the next session, we'll be doing the next session on Monday as per Eastern time, US time, and as per Tuesday as per Indian timing. So if I have to quickly recap today's session, what we discussed. So in today's session, we discussed about Oracle Goldengate architecture, how data flow happens. So extract process captures the data, write to local trail. Pump process reads the data from local trail and writes it to remote trail, and then replicate applies it to target database. Then we discuss about these virtual boxes, which contains database 19C and 21C Goldengate binaries are there. So for Goldengate binaries, before download and install, make a note of below: source, database type, version, platform, target database type, version, and platform. Before you can proceed with download and installation, always ensure you are checking the certification metrics. From certification metrics, you can decide. And then before proceeding with the installation, you need to define where you want to install Goldengate. What are the hardware requirements related to Goldengate, like number of CPU, space requirement, and then with which user you're going to install Oracle Goldengate. Okay. So any question, if you have, you can ask.
Yeah, sure. So this is Anish. Can you get this like note? You are like, the going through this note. Can you have this?
Yes, this will also be uploaded on the portal as well, and you will also receive it on the WhatsApp group as well.
Okay, yeah. If I get this note, then it should be good. Yeah.
These notes are uploaded on the portal along with the recording, and also these are also shared on WhatsApp group as
well. Okay, thanks. Bye.
Along with the notification and everything.
Ashish Obraj here.
Yeah.
I just need to know what's the use of data pump. I understand that it reads the data from the trail file, but why do we need it if we can directly write the data to the remote trail file, right? So why do we use pump?
So you will understand that as the session goes on.
Okay.
Today is your second day, just overview, download we are discussing. So as the session, when we do the configuration part, more things will become more clearer to you.
Okay. Thank you.
So
there is a question from Robin. We must be always now using integrated extract over classic. Yes, if integrated is supported, performance wise, everything, integrated extract is much better than classic. In fact, with database version 21C, classic extract you cannot use at all for Oracle database.
Okay. Yeah, got you. So one more question. So if you use integrated capture, so you don't have to use like integrated parallel replication. You can use classic one as well. Is this right?
I didn't get your question, Anis. So integrated is the
let's say
extract.
Yeah,
Yeah, so if
integrated
you are using
extract.
integrated extract, you don't need to use classic extract at all.
Yeah, no. Integrated extract and the replicate. When you apply the the log file in the target side, so you don't have to use replicated processes, right? You can use classic processes, a classic replication as well.
Yeah. So each, okay, yeah, absolutely correct. So the combination of processes which we discussed yesterday. So yeah, it is possible your source is using integrated extract, target is using classic replicate. Yes. Your source is using integrated extract, target is using parallel replicate. They are completely independent. Each process is independent of each other.
Yeah, that is my setup. That's what I'm just asking. So if I use the integrated replication as well, that would be better. Is it right, or it doesn't matter?
Yes, correct.
Okay.
Okay.
Right.
So any other question from anyone? If no question are there,
Ashish,
yeah, Kim, tell
I
me.
have a question. So I know when you were talking about the multi-tenant, right? Where you were talking about the Gate 1 and Gate 2, you talked about the container DB and the pluggable DB. So are those the source DB and the target DB?
Yes, correct.
Oh, okay. Thank you.
So guys, I hope you were able to follow today's session, and there is a lot more learning to come now. You will be learning a lot with this session going forward. Okay. So on that note, thank you everyone for joining today's session, and see you in the next session. Thank you.